All right, so continuing our discussion from Chapter 1, Section 4 with vectors, we're going to talk about the operations you can do with vectors. So for some of you, this might be review, and for some of you, it might be new. So we're going to go through it in detail just so that everyone's all on the same page. So with vectors, you are allowed to multiply them and divide them by scalars. So remember, scalars are one-dimensional numbers. They're numbers that you're probably more used to working with. So for example, you can multiply r by 2, giving you 2r, and you can divide our vector a by the scalar integer 6. You can do something called finding the magnitude of a vector. So whenever you're finding the magnitude of a vector, you're going to put it in between these two absolute value signs. We'll go through how you do this operation later. You can find the unit vector of a vector. So you could take your torque vector tau and find the unit vector. The unit vector gives direction. We'll go through the operations required to find that unit vector. And you can add one vector to another. So you can add vector h to vector k. Just like addition, you can also do subtraction. You can subtract one vector from another vector. So you can do k minus h, a perfectly allowable vector operation. You can also differentiate a vector. So you can take the derivative of a vector. If you take any upper level physics classes, like optics or modern physics, we do a lot of differentiation of vectors. We do maybe one or two in this class, if you're in the calculus version. So you can do dr, dt, look at the time rate of change of the position vector. Then we can do the dot product. So there's two ways to multiply vectors. You can do a dot product of two vectors. The dot product is also called the scalar product. And that's because if you take the dot product of vector E with vector F, it will produce a scalar result. So we will learn about doing dot product of vectors in Chapter 5. And the second form of multiplication is you can do a cross product of two vectors, and this type of multiplication will produce another vector. So you can do A cross B, and that produces a vector result. And we will learn this operation in Chapter 11. All of the other operations prior to the two types of multiplication, so we will do in Chapter 1 and be practicing them along. These will come later in the class. So moving on. There are a couple of operations that are not allowed with vectors. So they're illegal or meaningless. I never want to see them done in this class. So a vector not set equal to a scalar. That is a nonsense expression. Vectors are three-dimensional numbers, scalars are one-dimensional numbers. 3 dimensions does not equal 1 dimension. A vector cannot be added or subtracted from a scalar. That is also a meaningless operation, so you can't subtract temperature from velocity, which also makes physical sense. A vector cannot be a denominator. So now you notice that we're going to have to divide by some things, see two vectors in this class. What we will do in those cases is we will take magnitude of the vector. Magnitude of a vector is a scalar and can divide by magnitude. And just like scalars, number units are very important in this class. You cannot add or subtract vectors with different units. If you have two vectors, you're supposed to add or subtract the different units, you need to use unit conversion. Alright, so let's go through these some principles that are allowed to be done with vectors. So you can multiply a vector by a scalar. So for example, if we have vector r is x, y, and z. If we multiply r by scalar base, we have b times vector r. Now, this result would then whole b through the vector. So then you would have x would be scaled by b, y would be scaled by b, and z would be scaled by b. Anytime you multiply a vector by a scalar, you are scaling a vector by a quantity of the scalar. We're doing this a lot in this class. Now if we divide a vector by a scalar, look at how that looks. If we divide a vector by a scalar, we have that a is equal to s, a sub y, a sub z, and so we're going to divide a by the scalar j. So then the result is a s divided by a y divided by a z divided by pretty simple. Note if you multiply a vector by -1 over Jordan. So you pull that minus sign all the way throughout the vector. Always. So let's do just a quick example to illustrate the vector operations that you learned to do. Of course, if I'm moving to pass by moon notes, you'll be free to stop and catch the train. So, example, you are at position R is equal to 36, 48, minus 4 meters. Your friend is at minus R over 4. Where's your friend? So, in this case, what we do is take our vector R and we want to multiply it by -1. That's equal to -36 plus -48 plus 4 meters. And then we want to take minus r divided by 4. So this is equal to minus 4 minus 48 divided by 4 and plus 4 divided by 4. And this results in the final position of your front be equal to minus 6, minus 12, and okay, so you can take magnitude of a vector and write out a vector. Essentially the length. And we'll see the results. So, if we get essentially what you need your so power x-axis, y-axis will get your job drawing in through and vector here, and that links through inclusional theorem root of square plus y squared, so case square plus square plus y is the square root of that. So the magnitude of vector is fine. We have the vector A is equal to subtract a y a z, and magnitude of A is equal to x squared plus y squared plus a z squared. Alright, we'll stop here and continue.